Okay, so the idea that's going to connect this is that if the gears are adjacent, they're going to have the same linear speed. Like picture this belt has to be moving at the same speed no matter what gear it's on. It's just a belt that's moving at that same linear speed. But this wheel and the wheel sprocket have the same angular speed because if you were to mark a spot as they move, they're traveling at the same angular speed. So we're going to use that to kind of jump from pedal to pedal to pedal, because eventually we want to talk about the wheel, but first they give us the pedal, then we move into the sprocket, and then we move into the wheel. So they tell us that he's moving 40 revolutions per minute, and that's his angular speed. We don't really want revolutions per minute, we want radians per minute. So every revolution we know he's going 2 pi radians. So we've got 80 pi radians per minute as my angular speed of the pedal. And I'm just going to use my formula now that the linear speed for the pedal will be the pedal's radius times the pedal's angular speed. So if I want the linear speed for the pedal, which will let me connect to the sprocket, it's going to be 4 times the 80 pi, which is going to give me 320 pi, and this is like inches per minute. So now we're able to move into the wheel sprocket because we know that the linear speed for the pedal is the same as the linear speed for the sprocket. So if I write my equation again, that the linear speed for the sprocket will be the radius of the sprocket times the angular speed. I know my linear speed is 320 pi. For the sprocket, it's 2, and the angular speed is what we want to know, because once we know the angular speed, that'll be the same as the angular speed of the wheel. So just dividing, we get 160 pi is the angular speed of the sprocket, which is the same as the angular speed of the wheel. Now finally, we can talk about our wheel, and we know that the same formula, the linear speed of the wheel will equal the radius of the wheel times the angular speed of the wheel. So the radius of the wheel is 13, and it's going at 160 pi. So this is 13 times 160, the hardest part, 2080 pi inches per minute. And there we go.